So hey everybody, welcome to the session. Thanks for coming. And today I'll be talking about how embeddings can help you build these generative AI applications that scale. A quick introduction to me first. My name is Frank, officially Director of Operations, also ML Architect here at Zilliz. And those are my socials down there as well. So if after the presentation, after the talk, or even during the talk, if you want to sort of get in touch with me, I'm happy to take any questions, comments, concerns that you might have, or answer any questions related to the talk as well. And I definitely want to introduce the company real quick first. So Zilliz, we are a vector database company based out of beautiful San Francisco Bay Area. There's a link to our socials down there. And if for folks who are unfamiliar with what vector databases are, I'll sort of talk about that a little bit later on in this talk as well. So I'll leave those on there in case anybody there wants to connect. All right. So first things first, I'll give a quick overview of what I'll be talking about during this session. The first is a very, very brief introduction into auto-regressive language models. And I know, there's been a lot of hype and there's a lot of folks who really know a lot of detail about this, but this is more just a gentle introduction or a gentle reminder for how a lot of these auto-regressive LLMs work in case folks need them. Then I'll be talking about the CVP framework. And the CVP framework is really something to help mitigate a lot of hallucinations and a lot of these problems that auto-regressive language models have. I'll talk a little bit more about hallucinations, why they come to be in the first section as well. Then we'll do a deep dive into Milvis. Now, Milvis is the world's most popular open source vector database. And again, during section 2, you'll see how Milvis fits into the CVP framework and what it can really be used for. And finally, I'll sort of end off with a quick demo. So if you guys stick around for long enough, hopefully that'll be pretty interesting for you as well. So yeah, auto-regressive LLMs, right? Or large language models or foundation models, as a lot of people like to call it as well. And what are they, right? And what are they and what are they good for? I won't really talk too much about the applications or sort of layers above these large language models, but we definitely know that there's a lot of craziness. We're in a huge hype cycle around ChatGPT, around a lot of these generative AI models, right? And there's also a lot of other ones coming out as well. Claude and Bard are also currently in experimental mode, and there's many, many more that will be coming out this year as well. And it really, really helps to sort of see how we got to where we are today. And if you look at where deep learning started, a lot of it was really centric around computer vision. The idea that if I take what's called here, what you see here, sort of a context window, convolutions really attend to nearby positions within your input tokens. And that's a pretty simplified view of how convolution works. And again, convolutions are typically applied to computer vision applications, but this can give you sort of, hopefully this gives you insight into where we came from and where we're going, right? So convolutions have this very, very sort of a fixed length. They have a very, very small context window. And if we go to self-attention, inside a neural network that is trained with self-attention or that has self-attention blocks, the context is fully global. So you can see here, if I go back to this example, Milvus is the world's most popular open source vector database. Database is missing. You'll see why in a second. You can see that portions towards the end of the sentence, it's very, very difficult for them to have context relative to the earlier portions of the sentence. And self-attention is really something that helps fix that, right? So again, we have this global context, and you might be wondering why the rest of the sentence isn't here. It's because I got tired drawing all these arrows, so I apologize for that in advance. But moving on from self-attention, if we look at sort of how a lot of these generative models work, or how they're able to generate text so well, they use something called causal attention. And causal attention essentially is where words that are later on in your sentence or later on in your sequence can attend to positions that are a little bit earlier. So in this case, world can attend to Milvis, but not the other way around, right? Otherwise, it wouldn't really be a generative or a cause and effect type of model. And a key takeaway from all of this is that a lot of these generative models are stochastic. They're probabilistic. They're used to predict future tokens. Now, if we go here, For example, we use Milvus is the worlds to predict what might come after that, right? In this particular example that you see here, Milvus is the world's most popular vector database. It could also be a vector search engine, vector embedding engine. These are some of the potential sort of tokens that could be used to fill in this sentence that you see here, right? And a major downside to all of this is that it introduces hallucination, where there's sort of plausible sounding, but actually factually incorrect responses generated by LLMs, generated by these autoregressive models. And, and these hallucinations really are a pretty big problem, I would say, for really putting a lot of generative AI, text AI applications into production. I know a lot of folks enjoy having a mathematical foundation to a lot of how some of these things work. And essentially the goal here is that we have some tokens and we want to predict the next token after that. And what generative AI models do is that they simply model the probabilities that a particular token comes after your input set of tokens. So in this case here, the probability that my next token is a database, given Milvis is the world's most popular vector something, would be the highest. This would be something that a trained generative model is, this is the probability that I could potentially output, right? And again, going back to the topic of hallucinations, I sort of stole this particular diagram from Jan LeCun's slides. A big reason, if you look at these models from a stochastic perspective or from a probabilistic perspective, I think you can see why they hallucinate, right? You have these input tokens, and perhaps you want to generate 1,000 words or 2,000 words of text, and all of a sudden, if you have one word that is wrong, your entire result can be a little bit off track. And that is really one of the, I would say, this sort of combined, this combined reduction in probability of the output being correct is really one of the reasons that hallucinations occur, right? So a big way that, well, not a big way, one way that we can use, and I would say the main tool that we can use to solve the problem of hallucination is something that we call the CVP framework. And I'll talk a little bit about what CV and P mean in the next couple of slides. But first, I want to give an example of what hallucination is, right? So if I query ChatGPT, or if I query, let's say, any other autoregressive language model with how do I perform a query using Milvis, Milvis being a vector database, which again, we'll get into, you'll actually see that the answer looks right for the most part, right? But it actually isn't. And the reason is because in Milvis 2.0, there is no notion of a Milvis client. And instead, what's happening is that the connections are done via connections, right? The solution to hallucination, and again, this ties in very much with the CVP framework, is to inject domain knowledge into these LMs. And what I mean by domain knowledge is that if you are, let's say, a financial institution, or you're in the security sector, you may want to create, let's say, an internal chatbot, or you may want to create something that is really targeted towards the application that you're trying to build. And by finding relevant documents, by finding documents that are relevant to your query input and having that as prompt in, let's say, ChatGPT or anything else, that can help you significantly reduce hallucinations and give you better results overall. So let's go back to the previous example here, where there's clearly Milvis being hallucinated here. If we instead put it in this demo that I'll show you in a little bit later on, we can see that it actually fixes the problem, and now we use connections rather than this hallucinated Milvis client, right? So again, this is one example of how we can use domain-specific knowledge to really fix a lot of these hallucination problems that ChatGPT presents, and some of these other autoregressive models as well. Okay, so now I want to talk about this CVP framework, right? And this is really, I would say, the bread and butter for what I think a lot of future applications that leverage LLMs is going to look like. And the key idea here is that we can view a lot of these apps built atop large language models or autoregressive language models as a general purpose computer. And it'll sort of, hopefully this will be a little bit clearer in the next couple of slides. But the first thing that you need is a processor. On top of the processor, you'll need some persistent storage, and you'll need code that takes what's in that storage and does some useful work, some useful computation over it, right? And this is really where C, V, and P come into play. C, in this case, being ChatGPT, or any other large autoregressive language model. And you can really interpret ChatGPT as a processor. You can really interpret this model as a large processor block for the CVP framework. V is any vector database, Milvis being an example of a vector database. And this can be interpreted as the storage block for CVP, right? And you might want, let's say, you may want some other cache layers as well. We can get into that a little bit later. P in this case is prompt as code. And this essentially just means that instead of in a traditional computer, we might have machine code, zeros and ones, that represent your instruction set architecture. In this case, the code is simply natural language, and we use natural language to really make the processor do what we want it to do. So that is C, V, and P, right? And how is this typically implemented in practice? I'll sort of, again, hopefully this will be much clearer as we progress through this presentation here. But the first thing that you would do is you would have a knowledge base. You would have a particular set of documents. Those would go through some deep learning models, and those get turned into vectors and use a vector database such as Milvus to perform nearest neighbor search. Vectors that are closer to each other are more similar, or they are more relevant to each other. In this case, you can imagine if I'm building an application on top of ChatGPT, I'll have queries and responses, and you can really map those queries to each other much better using embedding models, right? Now, this is a very, very simplified view of things. For example, you would, ironically, for an application that utilizes CVP, you wouldn't want to use autoregressive models to generate the embeddings. You would want to use something that's trained either using MLM or some other bidirectionally or just regular self-attention, right? So this is a very high-level overview and also a sneak peek for the demo that I'll do a little bit later. But this is something that we built internally here at Zilliz called OSS Chat. And OSS Chat, I think, is essentially a manifestation of the CVP framework. Essentially, what happens here is that we have first, we have the vector database, Zilliz Cloud. It is storing a lot of project information, about open source projects. And, where do we fetch this information? It's from GitHub, from the documentation, from a variety of sources, of publicly available sources about that particular open source project. These docs are then chunked. They are turned into embeddings and then stored inside of Zilliz Cloud, which is based off of Milvus. And then these then go into a pipeline where a user will ask a question. That question will get matched to a lot of the relevant documents inside of Zilliz Cloud. Zilliz Cloud will sort of find more or less the documents that pertain to the answer, and then ChatGPT will, using a lot of the relevant documents as prompt, it will figure out how to best respond to that question rather than just using whatever knowledge that it was trained on, right? So that's really OSS Chat as an application in a nutshell. And as I mentioned just a tiny bit earlier, OSS Chat is a manifestation. It's a great example of the CVP framework that we were talking about back here. Okay, awesome. So now that we know how vector databases fit into the CVP framework, how CVP can be used to really mitigate a lot of the hallucinations that you see with large autoregressive language models today, I want to do a bit of a deep dive into Milvis. Now, I won't spend too much time here, but really, hopefully, by the end of this section, you'll have an idea of what Milvis is and how you can use it to build a production-ready LLM application, right? And production-ready is something that we put a very, very strong emphasis on here at Zilliz and within the Milvis community as well. So a quick overview of what Milvis is. Milvis is an open source vector database that is purpose-built to store, index, and query large quantities of embeddings, right? And there's a link to Milvis down there. I highly encourage everybody to go take a look at some of our docs, download Milvis. It's free to use. Go ahead and play with it. And a key distinction between Milvis and Zilliz is that we are key backers of the Milvis project, and Zilliz Cloud, which is the managed service, is based on top of Milvis. So it's backed by many months and years of engineering work that has been put into building a solid production-ready vector database such as Milvis. And I want to talk very, very briefly about the Milvis architecture. Again, I won't go too much into detail here, but essentially you have 4 different layers, and I'll go over each of these one by one. Hopefully by the end of these couple of slides, you'll understand why Milvis is production ready, why it's scalable, and why we designed it the way that we did. So this is the Milvis architecture. The first thing that you'll notice is the access layer, and the access layer is really there to take user requests and route it to the right place. So I won't go too much into DDL, DML, DCL, but just know that the access layer is used to route your requests to the right place inside of Milvis. We have a coordinator layer here as well. There is one coordinator service for each of the different types of worker nodes. So we have query nodes, data nodes, and index nodes. And depending on the type of application that you build atop your LLMs, you might want to increase the number of queries that you do, or you might want to increase the number of inserts that you do. And we can do that. You have a very, very flexible way to do that inside of Milvis as well. The worker layer, as I mentioned, is composed of these different types of nodes that are stateless and do individual things. As you can imagine, query nodes are there to query your vector database, and index nodes are there to do the indexing. And there's a storage layer that is built on top of cloud native platforms as well. So for example, we have object storage based off of MinIOS 3, and then there's also message passing inside of the Milvis vector database as well. Again, I won't go too deep into this, but that is one of the main components there. So what are the key takeaways from this session, right? From this section, excuse me. The first is that there is a single coordinator instance per service type, and this is really a big reason why Milvis is so flexible, and why we've seen over 1,000 enterprise users across a variety of different industries that use Milvis today, right? Is because of that flexibility. Data in Milvis is stored in collections. Collection can further be divided into partitions. And we have very, very explicit disaggregation, not just of data and compute, but of the different types of compute as well, of querying, indexing, and data. And message streams are also really, really core to Milvis. And that's what allows us to do both real-time as well as batch processing. It's one of the reasons why Milvis has such a powerful architecture. All right, so now that we've gotten all of that out of the way, I do want to spend a little bit of time on a quick demo as well. Now, this demo will leverage OSS Chat, and as I mentioned a little bit earlier, OSS Chat, the architecture for OSS Chat looks a little bit like this. And again, to give everybody a bit of a refresher, essentially what OSS Chat has done is it has indexed a lot of documentation, a lot of code, from a lot of different locations about these open source projects. And those open source projects then get, when a user will ask OSS Chat a question, the data on those open source projects will get queried from a Milvis instance, in this case from Zilliz Cloud. They'll get passed into ChatGPT as prompts. ChatGPT will then answer questions about that. So this is the interface for OSS Chat. And what I want to do here in this demo is just do a simple side-by-side comparison of OSS Chat relative to GPT 3.5 or ChatGPT here in this case, right? And with the particular architecture that we've set up, OSS Chat is available for everybody to use. As I mentioned, I highly encourage you to come online, try it out, osschat.io. And what I'm going to do is I'm going to ask OSS Chat and ChatGPT 2 different questions about open source projects. And really, we'll see how the CVP framework can be used to fix a lot of the existing issues around hallucination, around lack of domain knowledge that we see in these generative AI models. So the first thing that I'm going to do is I'm going to ask OSS Chat about LangChain. And I'm sure a lot of the folks listening to this presentation have heard about LangChain. But if you are unfamiliar with it, LangChain is essentially an open source project that you can use to build a variety of different LLM applications. So the first thing I'm going to do is I'm actually going to ask ChatGPT, what can I build with LangChain? Whoops, let me refresh here. And as you'll see here, LangChain, it doesn't quite get it 100% right. So when I ask it, what can I build with LangChain, it says that LangChain is a new technology that combines the power of blockchain and natural language processing. A big reason why ChatGPT doesn't quite get it right here is simply because it doesn't have the right amount of knowledge. It wasn't trained on knowledge from the point that LangChain was created. But if I take the same model, which in this case, as I mentioned before, is GPT 3.5, I find relevant documents about open source projects relevant to LangChain. I can then get GPT 3.5 to answer the question much better. So let me do the same thing. I'm going to type the same question except in OSS Chat. So it'll think for a while here as it retrieves the relevant documents. And in this case, it gives a much better, albeit pretty concise, response. So you can use LangChain to build a variety of applications, as OSS Chat mentioned, such as QA, such as different chatbots, and a variety of other apps as well, right? It is a bit concise in this case here, but depending on how you prompt it, you can get a lot more information as well. From here, the second example that I want to give is related to Milvis. And it is very similar to the example that I gave earlier, but I want to show it to everybody here in action. Now, ChatGPT, or GPT 3.5 Turbo, however you want to call it, it has a lot of information about Milvis internally as well, and it has relevant documentation too. But in this case, because of, it just doesn't quite get it right. So let me type the prompt here. Where I'm going to ask GPT to tell me how to query a Milvis vector, an instance of Milvis, a Milvis vector database. Very similar to the example that I showed above. I'm asking it to show me some Python code as well. And as you can see, unfortunately, it doesn't quite 100% get it right. Milvis, in this case, the interface with Milvis is actually done through connections and not a Milvis client, as you see here. But if you were new to Milvis, or you were figuring out how to use it, this sounds very plausible. It sounds very reasonable, and you might say, hey, I'm going to use this code, I'm going to try it, and hopefully it works, but it won't quite work, unfortunately. If I inject GPT 3.5, ChatGPT, with more domain knowledge about Milvis, which I'm going to do in OSS Chat here, I'm going to type the same exact query. Do the exact same query here, you'll see that it actually gets, or it gives, a much better response. So I'll wait for it to finish thinking there. And again, as I mentioned a little bit earlier, comparing these two side by side, you'll see that while ChatGPT gave me a response that involves a non-existent Milvis client, even though all this sounds very reasonable, in this case, OSS Chat, which essentially leverages vector databases, leverages Zilliz Cloud Milvis plus ChatGPT, it gives me a much better response. It actually gives me, in this case, a correct response as well that leverages the connection object from PyMilvis, right? Now, these are just 2 examples of a wide variety of ones that you can use on OSS Chat. And now we're continuing to add projects every single week. So if there's any favorite project of yours that you want to see here on OSS Chat, let me know, shoot me a message, and we'll see what we can do. Right. One last thing that I want to mention about OSS Chat, as you use it, you may find that some responses are much, much quicker than others. And simply the reason for that is because we have integrated a new project of Zilliz is called GPT Cache, one word, GPT Cache, inside of OSS Chat that allows it to cache some of the most commonly asked questions. So if you see in some instances OSS Chat responding very, very quickly, that is the reason why we've done that there. If anybody's interested in GPT Cache, which is essentially a semantic cache for large language models, feel free to Google it, or feel free to get in touch with me as well. Happy to send you a link to the open source code that we have on our Zilliz repo. So that is the end of the quick demo that I wanted to do there. I'm going to stop sharing. And that is really the end, right? Again, as I mentioned earlier, OSS Chat is available for everybody to use. I highly encourage you to go try it out, play with it a little bit. Would love your feedback. And let us know if there are any other open source projects that you want to see on this website as well. So thank you, everybody, for bearing with me through this session here. Feel free to visit Zilliz.com, or if you're interested in Zilliz Cloud, visit Zilliz.com/cloud to learn a bit more. And yeah, happy to take any questions or any other sort of comments or concerns that folks might have as well. Thanks for listening.